Large language models have proven their place in supportive and supervised tasks, but can we trust them to do independent work? This is the big question that shoots down many promising use cases where we just can't accept their hallucination or inaccuracy. But what if we approach the problem from another angle and pick a domain where screwing up and breaking things is a standard practice? That's right, I'm talking about testing. And I'm not talking about test automation in its traditional meaning. I mean handing the whole test scenario over to an AI as if it was a human tester. It's easiest to explain this as a demo, so let's go. Our demo application is called AI Test Pilot. It takes two inputs, the URL of the test target application and a human-readable test case. It uses the remote-controlled browser on the right side of the screen to perform testing autonomously. In the first example, we are testing a website providing a variety of calculators. In our test scenario, the expression 10 divided by 3 is executed using the scientific calculator. The acceptance criteria expects the result to be given as an integer without decimals. As you can see, the tool is able to observe and navigate the application under test. It finds the correct calculator and uses the correct buttons to input the expression requested. The observations and actions are printed to the test log on the left side of the screen. Eventually, the tool is able to complete the calculation and conclude the test case result. In this case, the test fails because the result was not an integer and indeed had some decimals presented. Okay, great! Let's move on to our next example. This time I'll be explaining a few more details. The second test is for the IKEA webshop. The point of the scenario is to use an invalid discount code in the shopping cart and verify that the produced error is correct and human-readable. The test pilot tool uses LLM in multiple roles. First, it creates a high-level plan for executing the given scenario. Then it runs an iterative test loop as long as needed to complete that plan. In each loop, LLM is prompted 2 times. The so-called observer follows up the testing progress and application status. It evaluates if the test result can be already concluded or if testing should be terminated due to not making progress. However, in most cases, the observer is able to figure out the next testing task or a question that is then handed over to another LLM called the agent. The agent has the tools for interacting with the website. It uses image-based navigation for a human-like approach. After executing the most reasonable action, the agent reports this back to the observer together with a description of the application state. The observer then evaluates the situation again and the loop moves on. In the test scenario, we gave very limited instructions for the AI. For example, we didn't tell it to pick a chair or how to add it to the shopping cart. Still, it's able to figure out these necessary steps and eventually enter the shopping cart view. Hidden elements, such as the discount code panel here, might be challenging. The visual navigation approach helps to identify the visible items instead of the hidden ones. Now that the tool has found the correct field for the discount code, it is time to input the invalid data. It is also crucial to collect the exact error message for deciding the test result. In this case, the test passes because the message appeared and matches the given criteria. Let's try yet another test case. This time we are working on the Finnish railway ticket service, probably familiar to all locals. The point of the test case is to purchase a trip between 2 cities, Vaasa and Tampere. The acceptance criteria expects an add-on service called cancellation protection to be offered with the price tag less than 10 euros. This is a good example of a criteria which is at the same time specific but doesn't place assumptions how the offer is being made. In this specific application, the cookie consent is mandatory. For this reason, our tool has to instruct the AI to allow this kind of side quests that are not directly valuable to the test case. As you can see, we are also operating the app in Finnish language this time. It's not a problem at all, because translating languages is a built-in feature of LLMs. Modern UIs are often very dynamic, but the AI is still pretty good in using them. Sometimes there are multiple ways to perform the requested scenario. This might naturally lead to slightly different test steps each time. It is also possible that AI makes a mistake, but is often able to step back and correct it. For example, here, the calendar view is opened with no true reason. Soon enough, the tool understands to close it and revert back to the correct test flow. Similar to human testers, this approach involves a level of non-determinism. This is the main difference when compared to standard test automation. Again, with very little instruction, the tool was able to search and select the trip and continue with the purchase process until the add-on services screen. The test passes because the expected cancellation protection service was offered with the price less than 10 euros. This is the kind of stuff we have to do all the time at Wapice to retain our tech advantage as a supplier. Not all research is this cool, and we have to also be able to fail fast in this business. But this time I was surprised how well the idea worked. Large language models fit to this purpose due to the following key features. 1. Their creativity and ability to take initiative. 2. The ability to process abstract data, even images. And 3. The ability to interact with tools and interfaces in a logically correct manner. The concept requires more development, but we have a good starting point. The prospects are not limited to web applications only. However, we need a clever alignment with regular test automation. But one thing I'm totally sure about: AI will change testing and it'll happen faster than you think.